is graph reading. So this is how to read graphs and get stuff out of it that they're going to ask you about, right? So this is the typical plateau graph. And you guys, most of you didn't take physical science, correct? So you never did this experiment, but there's one of the things you can do is they'll give you like this alcohol, like ethanol or methanol or something like that. And they all have different boiling points, right? So you heat them up, and where they boil, you'll see that the temperature go up, 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 and then it really does plateau. It goes level for a while, right? And then where it goes level is the boiling point of that alcohol, right? And usually, I think alcohols boil at a lower temperature than water or something like that, right? So you get like several plateaus sometimes if it's a mixture of stuff. But anyway, concept zero is that melting point and boiling point are temperatures. Yes? So what are the temperatures? Where does it melt and where does it boil? Yeah, we got to read the graph, right? What's the melting temperature and the boiling temperature? So point means temperature, right? What is it? Yeah, it looks like 25-ish, right? It looks a little low to be 25, but I tried to make it 25, right? Okay, so between 20 and 30, about halfway, right? And then what's its boiling point? 75. And this is an intrinsic property of the matter. You can look up what it is. You know, if you knew those two things, there's probably very few other things. This is just made up, so it's not really anything, right? Okay. And the next thing is that we could determine the specific heat of the solid phase. I think we could, couldn't we? Yeah? Well, in order to figure out specific heat, we've got to use this formula, don't we? Don't we? Yeah. There we go. Which means that we have to read the graph and determine what Q is and what M is and what delta T is. Does anybody know any of those? Hayden's got 0.45. Where did you read the graph to find that? Yeah, it's like written in the title of it. Somebody has to tell you the mass. You can't really read that off the graph. Okay, but in this case you can. I can't tell you how many, by the way, classes full of students will get down to mass being the last thing and they'll be like, nobody gets it. 0.45. Oh. What else can we get? How much heat flows in? By the way, this really should be a delta Q, a change in heat, like, yeah. 75, 50. So remember, this axis here is how much heat is added. And where is the solid? Just that line segment, correct? So basically we're trying to read this line segment. This would be delta Q. This would be delta T, wouldn't it? The change in Q, the change in T. So what is our delta Q? 5,000. Yeah? Okay. So this guy's 5,000. Yeah, and then each one is 1,000, right? Yeah. And then what is our delta T? 25. 0 to 25, that's pretty easy, right? And then as you can see,
it's so funny.
There's only one variable, right? Yeah? So take your calculator out and solve for that. Take out your calculator. A lot of what? It is a lot of fours. Yeah. And write it on a whiteboard and give me the right units. That's the hardest thing. Nobody can give me the right units ever. Oh my God. Yeah, let me sign that pass.
Why do you need to sign it?
Do we write randomly on anything else? You got another piece of paper. Give me that.
You got an eraser? No, this is fun.
Yes. I didn't know you said. Oh, the thing for.
Yeah, there you go. Yes. Now people get kind of confused. Should you say, now give me 2 sig figs and give me units. That's right. Should you say joules per degree Celsius kilogram, or should you say joules per kilogram degree Celsius. That's right. And the answer is it doesn't really matter. But yeah, your sig figs are a little exuberant. Where are your units? No, Ray. Write them bigger. Give me 2 sig figs. That's right. That's right. Yes. 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 Hey, I want you guys to know that's right. I did something I've never done before. That's right. I went to Byram. I was dropping something off for the union before school, and I went in, and when I was dropping stuff off, there were like kids coming in there, which made me kind of nostalgic, right? The elementary school kids are so small these days, right? But anyway, I actually went out of Byram the way you're supposed to, because I figured I better like be a good guy when there's like all these people around watching, right? And I found my way back to Boone's Ferry Road. I took every left turn. Which by the way was not right. What you should do is go to Martinazzi and then go to that one street which takes you right back. But all the other ones are like little tesseracts. It's like a maze back there. Yeah? There's like 2 left turns. Like you leave Martinazzi, you end back up on Martinazzi. Dang. Next left turn. Leave Martinazzi, back on Martinazzi. Martinazzi is like this street that exists in like other dimensions. You guys read The Golden Compass? Yeah, kind of like that. I'm afraid of that neighborhood. It's like,
You should not live in that neighborhood.
yeah, Bermuda Triangle. You're probably used to that. You're immune to the effects of the gravity vortex or something. What's the next question? Next question. What is the specific heat of the phase liquide? Now I'm going to tell whether you're really reading the graph, because we're talking about change in temperature, and the change in temperature is definitely not 75 for the liquid phase. Where's the liquid phase?
50.
There's the liquid phase. The change in temperature starts at 25, ends at 75. The change is therefore 50. The heat starts flowing in at 15,000, stops flowing in at 35,000. What's the change? There you go. Yeah? Yeah. Yes. Make it degrees Celsius though. That's right. What did it do to you? That's right. Yes. I don't get that number. That's right. Unless you're like rounding badly. That's right. It's like 10 times that much.